Balancing half reactions in basic solutions is a bit different from balancing half reactions in acidic solution, in the sense that in acidic solutions we balance with electrons, right? Then we balance with water, and then we balance with hydrogen ions, also balance with hydrogen ions. But in basic solution, balancing half reactions in basic solution, we balance with electrons, good, we balance with water too, okay, and then we balance with hydroxide ions. So the basic difference is in basic solutions, balancing half reactions in basic solutions, we balance with hydroxide ions, while in acidic solutions we balance with hydrogen ions. Then the next question will be, how do you know if the half reaction you're given is in basic solution? Okay, sometimes it is explicitly stated in the equation, in the problem that you're given, that this is in basic solution, or sometimes you can see in this reaction arrow, the examiner can indicate OH minus, sorry, this is minus, can indicate OH negative on this reaction arrow, or you can identify a strong base. Once you can identify a strong base as the reactant, you can easily tell that this is a half reaction in basic solution. So let's quickly look at some examples. Okay, one or two examples, and see how we can balance half reactions in basic solution. So the first example, let's look at let's take this. Have lead dioxide, okay, and okay, good, very good. Let's balance this half reaction. So this reaction that we're about to balance is in basic solution, so let's see how we can balance the reaction. Okay, first let's just the way we balanced in acidic solution. First we balance the element, this atom, okay, that is to be reduced, that is being reduced or being oxidized. So we're going to count. On our left hand side here we have one lead, on our right hand side here we have one lead. Okay, so we can say lead is balanced on both sides. Okay, so now the next is to balance oxygen. We have one oxygen on our right hand side, while on the left hand side we have two oxygen. So to balance oxygen, like we said before, if you watched our video on balancing half reactions in acidic solution, we said to balance oxygen we introduce water. So let's rewrite this. So we're going to have lead, okay, so we're going to add what? We're going to add water to this side, okay, so we're going to add this, so we're going to add water. Okay, if we're going to add water, that will be one, good, right? So we have two oxygen here, okay, and then we have one lead here, okay, and we have two oxygen here. So we can say oxygen is balanced, but then we've introduced hydrogen. Okay, so let's solve for this hydrogen. Therefore we'll have two hydrogen plus here. Okay, so now we've balanced hydrogen, we've balanced this hydrogen that we introduced, we balanced the oxygen, and we balanced lead. Okay, so and then, but we've not balanced the charges, so we have two positives here. So to balance this positive, we introduce two electrons. Okay, so we can now say we have balanced the charges here. So on our left hand side we have a net charge of 0, on our right hand side we have a net charge of 0. But looking at this equation, this is a basic solution, so we don't use hydrogen ions to balance basic solutions. Okay, so this is where we introduce hydroxide. If we're going to introduce hydroxide, we introduce hydroxide to this part, and we introduce hydroxide to the left hand side, and we introduce hydroxide to the right hand side. Okay, if we introduce hydroxide here, the OH will react with our hydrogen. For example, if you look at this, if you have hydrogen ion plus OH ion, you're going to get water, right? Okay, so if we introduce our hydroxide to this on our left hand side, it's going to react with this, our hydrogen ions and to form water. Okay, good. So that's what we're going to do. We're going to introduce 2 hydroxide on both sides. So if we introduce that, we'll have 2 electrons here, plus if we introduce 2 hydroxide, we'll have on this side, we're going to have 2 water. Okay, plus our lead dioxide. We're introducing hydroxide to both sides, so our hydroxide will still appear here. So we have lead oxide plus water plus our 2 hydroxide appearing here too. Okay, very simple. Now let's look at the charges. Okay, we have 2 negative charges here, then we also have 2 negative charges here. Good, our charges are balanced, but there's a problem. We have duplicate molecules in both sides. So we have 2 water here, and we also have water occurring here. So what will happen, we need to remove any duplicates, and that's the final step. So we remove water, this, okay, remove 1 water here, so remove 1 here. So our balanced equation will be 2 electron plus 1 molecule of water. Okay, then we have our lead dioxide, then we have our lead. Okay, now we've removed this water, so we're just going to be left with 2 hydroxide ions. Okay, so now our equation is balanced. We have equal charges here, we have equal charges here, we have the same number of hydrogen here, we have the same number of hydrogen here, we have the same number of lead, the same number of lead, and we have equal number of everything on both sides. Okay, so the next equation, let's look at another example. Good, let's look at another example. Let's solve something like, okay, let's use this. Okay, ammonia. Let's solve this half reaction. Okay, so if you employ the same steps that we used previously, this is what you get. We balance the nitrogen on both sides, so we need 2 nitrogen on this side since we have 2 here. So we're going to have 2 NH3 to give us N2H4. All right, good. And then if we've done that, okay, we need to balance the hydrogen on both sides. Okay, so to balance this hydrogen, we introduce just the way we do it when balancing acidic solutions. So we introduce 2 hydrogen here. So we can see that the hydrogen here is 2 times 3, okay, which is 6. So here we have 4 plus 2 hydrogen, so we have total of 6 hydrogens here, hydrogen ions. And then to balance, what we need to do, we have 2 positives here, so we need to balance, because here we have a net charge of 0, so here we need to have a net charge of 0 on this side too, so we add 2 electrons. Okay, but we don't, this is a basic solution like we did the other time. We don't use this to balance basic solutions. Okay, so this is where we introduce hydroxide to react with this. So if we have 2 hydrogen here, so we must introduce 2 hydroxide, so on the other side. So we introduce hydroxide on this side, and also on the left hand side, and also on the right hand side. So if we introduce hydroxide, we have 2 hydroxide plus our 2 ammonia, then we have this. Okay, and then our hydroxide, 2 hydroxide reacts with this to form 2 molecules of water. Okay, and then we have our 2 electrons. Very good. So now we look, is there any element? Is there any ion? Is there any molecule that is being duplicated that we can find here on the left hand side and also find on the right hand side? So we quickly check. There are none. Okay, so let's count our charges. We have two negatives here, we have two negatives here. Okay, and then we count our different atoms here, and they are all complete. So we can say now that this is balanced. So simply, this is how you solve, this is how you balance half reactions in basic solutions.